Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We are from Group 8 and for today's video we're gonna explain about catalytic reactor. So this video will be presented by Warushdam bin Mushah Jihad, Muhammad Hafiz bin Kamarul Zaman, Anas Aiman bin Malik Faisal, Muhammad Safwan bin Shamsuddin, Muhammad Adam bin Mahdi and Muhammad Mu'min bin Muhammad Rohaizat. So first of all, my name is Muhammad Safwan bin Shamsuddin, metric number 1182316. So basically, what is a catalytic reactor? Catalytic reactor is a device that contains space for reaction and houses the catalyst. It is also a container which uses reactants to make products and the reaction conditions that can be controlled. The example of reaction condition is temperature, pressure, density, and so much more. So let's look into the four classification on the catalytic reactor. The first one is size, which is big or small. The second one is charging or discharging method, which is batch or steady state flow. The third one is the motion of particles, and the fourth one is a fluid flow type, which is tubular or mixed fluid. So let's look into the method on characterization and properties. The first one is catalysts or surfaces should be carefully prepared and pre-treated. Why? Because some of the solid contaminants such as sulfur, chloride might affect the activity. The second one is support effects should be avoided. This can be done by studying reaction on a single crystal of active catalytic phase. The third one is preparation methods should be used by minimal degradation of the metal surface. Example is like the process of the decomposition of a metal carbonate on a support catalytic surface. The fourth one is the effects of surface structure or dispersion needs to be considered, especially for the sensitive reaction. The fifth one is metal dispersion or surface area should be measured using proven standard ASTM method. ASTM method is stand for American Society for Testing and Material. And the last one is methods of preparation and characterization should be reported in detail. This is a very important requirement for publication on a specific catalytic activity. So let's look into the mechanical properties. There are several properties which is density, pore volume, pore size and size distribution, surface area, catalyst, particle size, crushing strength, attrition. Attrition is the process of reducing material strength. So basically each of these properties have their own special definition or specification. So like I said in the previous slide, if you want to control the catalytic reactor, you must know this property properly. So basically, if you want to manipulate your catalytic reactor, or if you want to increase the rate of reaction or decrease, maybe depends on the industry wants, you must know how to manipulate this property well. So if you know how to manipulate property well, so you can control it properly.
My name is Muhammad Mu'min, metric number 1182335. Now we'll further with the type of catalyst. Catalyst can be divided into three types, which is homogeneous catalyst, heterogeneous catalyst, and biocatalyst. We will only focus on the homo and heterogeneous catalyst since it being used in the industry itself. For the homogeneous catalyst, by definition, it occupies the same phase as the reactant. For instance, hydrolysis of sugar catalyzed by hydrogen ion furnished by sulfuric acid. The advantages of it had a good contact with the reactant since it had the same phases. And the disadvantages of homogeneous catalyst is it needs to be separated after the reaction, and also catalyst recovery may be difficult because the temperature for the distillation can destroy the catalyst. For the heterogeneous catalyst, by definition, it occupies a different phase with the reactants. For instance, oxidation of sulfur dioxide to sulfur trioxide with the presence of platinum. The advantages of it can be separated from the reaction mixture, while the disadvantages of the catalyst, there is a low effective concentration of catalyst since the reaction occurs only on the exposed active surface. Now, how the catalytic activity of a catalyst is being expressed? It is being expressed in two terms, which is turnover number, or we call it TON, and turnover frequency, or we call as TOF. TON equal to the mole of substrate being consumed or mole of product being yielded over by mole of catalyst, while TOF equal to the TON over by time. Or in other words, TOF is a parameter related to the catalyst, which we call a TON, and the reaction rate, which involves the time. And you can see here, the higher value of TOF, we show that the reaction rate of the catalyst is also high. The rate of catalytic reaction, you can see here there are 4 different reaction rates they actually have in the industry. For the first is mass base rate, second heterogeneous reaction happen at surface, we also have heterogeneous reaction happen at this side, and last but not least we also have pseudo homogeneous reaction rate. So how do we calculate all these different reaction rate? So previously we know that the TOF equal to the TON over by time, and the TON equal to the mole substrate over by mole of catalyst. So the thing that need to be highlighted is the mole of catalyst, because all the calculation in this different parameter is quite the same, and the only thing that need to be changed is the mole of catalyst. Let's see the first reaction rate. For the mass rate, the TOF equal to the mole of substrate over by mass of catalyst instead of mole of catalyst, and over by time. You can see here the differ. It actually depend on the parameter itself. For the second reaction rate, which is heterogeneous reaction happen at the surface, the TOF equal to the mole of substrate over by area of catalyst over by time. And for the heterogeneous reaction happen at this site, the TOF equal to the mole of substrate over by site and over by time. And last but not least, pseudo homogeneous reaction rate, the TOF equal to the mole of substrate over by volume and over by time. So you can see here the only differ between this each differ reaction rate is how we determine the mole of catalyst itself. So let's dig in the heterogeneous reaction happen at surface, because this reaction rate is quite common in the industry itself. Exhaustion and reaction at solid surface. This reaction actually had two different mechanisms, which is phase absorption and chemisorption. Phase absorption actually occur due to the formation of van der Waals forces or weak forces, while chemisorption occur due to the formation of covalent or ionic bond or strong bond. The phase absorption is reversible in nature, while chemisorption is irreversible in the nature. Phase absorption also has low absorption enthalpy, while chemisorption has high exertion of enthalpy. For the phase absorption, it's favorable low pressure, while for the chemisorption it's quite vice versa, it has a favor high temperature. And last but not least, phase absorption results in a multi-molecular layer, while chemisorption results in one layer.
My name is Muhammad Adam bin Mahdi and my matric number is 1182292. Next, we are going to look into the heterogeneous catalysis reactor. But before that, you need to know what is the heterogeneous catalysis first. Next, we are going to go deeper on the type of reactor that is used in heterogeneous catalysis. One of them is packed bed reactor. Basically, packed bed reactor in chemical processing, a packed bed is a hollow tube pipe or other vessel that is filled with a packing material. The packing can be randomly filled with small objects like ratchet ring, or else it can be specifically designed structured packing. Packed bed may also contain catalyst particles or adsorbents such as zeolite pellet, granulated carbon, and so on. The purpose of packed bed is typically to improve contact between two phases in a chemical or similar process and to ease the product isolation from the catalyst. On the right hand side of the slide, you can see the picture of a packed bed reactor. Next is the other type of reactor used in this reaction. It is the fluidized bed reactor and the slurry reactor. For both of these reactors, it has been explained clearly by our friend in the past few weeks. For saving time, I will not explain more. If you don't understand about this, you may refer back to their slide or their video. Next, we are going to look into length scales in heterogeneous catalysts. For the first figure, we can see the reactor. The reactor is basically in meter, and if we zoom in, and we look into the reactor, we can see the catalyst itself, which is the catalyst is in pellet size. It can be in granular or powder size, but in this slide, we show it is in pellet size, which is in millimeter. Next, if we zoom in more into the pellet, we can see the surface of the catalyst, which contain the pore in it. Next, if we zoom in more, we can see the place where chemical absorption and reaction occur. The triangle one is the active site, the green one is the reactant, and the blue one, these two, is the product. So the first, the the reactant or the starting material will bind with the active site, and then the reaction occur. After that, it will produce product, and the product will dissolve from the active center. Next, I will talk about the heterogeneous support catalyst characteristic. For the first one is the surface. The amount of internal support surface need to be accessible to a fluid. Next, it is measured by gas adsorption isotope, which is Lama and French. For the loading, to calculate the loading is the mass of transition metal per mass of support, and for dispersion, the percent of metal atom need to be accessible to a fluid. For extra information, the function of catalyst support is to fix the active component. Next is to make the active component more stable, and the last one is to make the surface area larger, which will allow more reactant react with active site at one time. Next, to give you more clear picture on how the support catalyst work, we provide this picture, which is the hydrogenation of alkyne. In order for this reaction to occur, it will need palladium as catalyst. As you can see, this is palladium, and this is silicon oxide. In other words, this is the active component, and this is the catalyst support. In general, this both is called the catalyst. The silicon oxide or the support will make this reaction run smoother or run better. That's all from me. Hope you all can understand. Thank you.
Okay, Bismillahirrahmanirrahim. My name is Muhammad Hafiz bin Kamruzaman and my metric number is 1182315. Let's take a look on how to measure the concentration in heterogeneous reaction kinetics. Today, we are so lucky because there is no calculation to be solved, and this is just for a basic understanding on how to measure the concentration that related to the formula and the units. As we can see, it will be divided by two components, fluid concentration and surface concentration. Fluid and surface. Do you familiar with this formula PV and RT? This formula is for ideal gas law and also known as ideal gas consumption. But for your information, this formula is also used in batch reactor to measure the fluid concentration. And why we use this formula in batch reactor? Because we have already all the parameters. We have all parameters that important to measure the fluid concentration, which is pressure, and the unit is torr, atm or bar, and this is the conversion of the units, and temperature, and also the volume. We have three important parameters, which is pressure, temperature, and volume that we can use in this formula to calculate the fluid concentration. And next, for the surface concentration, it related to the coverage per unit area, and the unit is moles divided by area. And for the maximum coverage is called monolayer, ml. One monolayer is about 10 to the power of 15 molecules. For the fractional coverage, it must be in fraction. Theta is equal to n divided by n max. Okay, this is example for the fractional coverage for the metal particle surface. Okay, if we calculate the yellow one about 30 and the orange is 6. If we calculate the answer, theta, okay, 6 divided by 30, yellow one, and plus, because it includes the n max, plus 30 plus 6. The answer is 1/6. Okay, next, this is an overview on characteristic of catalyst and method for analysis. There are several characteristics of catalyst: surface area, pore volume, pore size distribution, elemental composition of catalyst, morphology, catalyst reducibility, and many more. And it has their methods on how to analyze the characteristic. For example, if we want to analyze elemental composition of catalyst, we can use atomic absorption spectroscopy, AAS. Okay, this is an instrument called Brunauer Emmett-Taylor BET surface area analyzer. Okay, it can analyze surface area, pore volume, pore size, and also pore size distribution. Example of sample to be analyzed: silica gel, activated carbon, and controlled porous glass, CPG. The price of this instrument is about 40,000 until 50,000 ringgit. Okay, this picture is AAS, atomic absorption spectroscopy. It can analyze the elemental composition of catalyst. Example of sample to be analyzed is metal loading of catalyst, which is supported gold catalyst. The price is about 30,000 until 40,000 ringgit. This is scanning electron microscopy. This instrument can analyze the morphology of catalyst. What is the meaning of morphology? Morphology is a study of the form of things, and it relates to the particular form, shape, or structure. For example, the nanostructure of the catalyst. The price is about 240,000 until 312,000 ringgit. This is transmission electron microscopy, TEM, used to view thin specimen, tissue section, molecules, and etc., through which electron can pass generating a projection image, can analyze dispersion, surface area, and particle size of active metal on the catalyst. The price is about 395,000 until 416,000 ringgit. Okay, this is temperature program desorption, TPD, and it can measure acidic and basic site strength. It comes with ammonia TPD or carbon monoxide TPD, and the price is about 71,000 until 112,000 ringgit. This is temperature program reduction, TPR. It is for catalyst reducibility, and it can analyze the characterization of solid materials and can find the most efficient reduction condition of the catalyst. And the price is more cheaper. It's about 29,000 until 34,000. Okay, this is X-ray photoelectron spectroscopy, XPS. It can analyze surface bulk composition of catalyst. The surface sensitive quantitative spectroscopic technique based on the photoelectric effect that can identify the element. This is how it works, and the price is about 1,216,328 ringgit until 4 million ringgit plus.
Okay, next we look at the application of catalytic reactors. In the industrial sector, almost all chemical industry use catalysts. If you notice from the slides before, all of the reactors that has been used in different types of industry all use catalysts, no matter if they are solid, liquid, or gas. That's because the catalyst has many benefits compared to not using catalyst. Number one, it has better economic process and productivity, which means it can create more with less time taken. Then next, it reduces industrial waste. Because catalyst remains unchanged during the process, there is no extra waste produced during the reaction. Next is better process control. You can see that using catalyst, we have better control over the rate of reaction, so we can determine whether we want the reaction to go fast or want it to go slower. Also, some products require catalyst to form. If we do not have catalyst, some products will only form naturally in little amount or not at all. That is why catalyst is important in the industry. Also, catalytic reactors encourage the technological development of industry itself. Next, we look at the environmental sector. Using catalytic reactors, the pollution it will enable us to control pollution from the industry, and it will reduce pollution form, so there will be less industrial waste in the nature after the reaction takes place. Other application of the catalytic reactor, it also encourages technological development because of the wide variety of possible reaction that can happen because of the catalytic reactors. Bismillahirrahmanirrahim. My name is Wan Rustam bin Wan Syajihan, metric number 1182318. Now I would like to explain the different types of equipment for data analysis as well as their specific function. The first one is the chemisorption analyzer. It quantitatively measures the number of surface active sites which are used to promote a specified catalytic reaction. As we all know, active site is where the reaction takes place. So the more active sites there are on the reactant, the faster the rate of reaction. Second is the TGA and DTA analyzer. It uses the method of thermal analysis in which the mass of the sample is measured over time as the temperature changes. The TGA measures the change in mass, and the DTA measures the change in temperature. The material under study, which is the sample, and an inert reference material are made to undergo identical thermal cycles while recording any temperature difference between sample and reference, which means there will be a comparison between sample and reference that is used to analyze the data. Finally, we have coke measurement and TPO. It is a measurement in formation of metal oxide or coke through temperature program oxidation, which involves thermal heating until oxidation occurs.
My name is Anas Aiman bin Malik Faisal 1182307, and now I will explain about the basis for catalytic reactor classification. There are several bases and classes for catalytic reactor. The first basis is size. There are four different classes for size, which is first is laboratory, bench scale, which is larger than laboratory, pilot scale, and intermediate scale, and used as for investigation of product before the use in the industry, and also plant scale, which is large scale and used in the industry. The second basis is method of charging and discharging. There are flow or steady state, which is an open system, means that it can charge and discharge during the reaction. And there are also a batch, which is a closed system, means that it can only enter once, and then we have to wait until the reaction is done. And here is the example of the reactors. The third basis is motion of catalyst particles relative to each other. There are relative motion where the catalyst move along with the reactant, and also fixed where the catalyst is fixed and only the reactant move. The fourth basis is fluid flow, where we have a mixed fluid flow where the reactant contents are well stirred and uniform throughout the reactor. And also we have tubular plug flow, where the reactant will undergo reaction along the tube. Okay, as I explained earlier, there are four sizes of catalytic reactor. Now I will explain more detail about the classes that exist in the laboratory and bench scale reactor. The first class is fixed bed tubular. We have laboratory differential or integral, which is this kind of reactor is used in the study of reaction, and also bench scale integral, which we can change the thermodynamic state throughout the reactor. And here is the features of the respective reactor. The second class is stirred gas fixed bed. We have stirred batch in which the reactant is stirred and flow while the catalyst is fixed. We also have the batch recycle, where the reactant will undergo reaction here with the catalyst, and then the catalyst will be separated and used again for this reaction. We also have Berti, in which the reactant is fixed here in this rotating basket, and the reactant will flow in and will be sucked in the basket here, and the product will flow out. We also have Cabri, in which the reactant is fixed, different from the propeller, and the reactant will spin here and react with the catalyst and go out as the product. The third class is the stirred liquid or gas stirred catalyst. We have stirred batch, in which the catalyst, liquid or gas, will be stirred together with the catalyst here using propeller, and also bubble slurry, like we have learned in the previous presentation. The fourth class is fixed bed transient gas flow, in which the reactant will flow momentarily varied while passing through the catalyst. We have an example here, which is the pulse flow reactor. And the fifth class, we have a fluid bed, which is the fluid, gas or solid reactant will pass through a solid granular material catalyst to suspend the solid and cause it to behave like a fluid. And here is the example. So we know the types, the classification of the catalytic reactors. Now we have to know the criteria of reactor. that we should use and how to meet the criteria. So the first criteria is the reactor must be able to satisfy the purpose of application. After we study the reaction that we want, next we have to measure the intrinsic or nature of the activity and selectivity of the reactor. We also have to measure the kinetics of reaction and the activation so that it will match the reaction that we want. And also, we need to understand the mechanism of the reactor and able to simulate and predict the process. Second, avoid catalyst deactivation and complication. After we have know the catalyst that used in the reaction, we must decide if the catalyst decay is slow or fast. A fast decay catalyst will cause the activity and selectivity disguise, which means that it be concealed and hard to read and require transport reactor. Thus, we will favor more towards the slow decay catalyst. And slow decay catalyst is best studied using CSTR or differential reactor before we use it in the reactor that we want to use. The third criteria is minimize interparticle and intraparticle heat and mass transport gradients. Interparticle is the porosity between the particles, and intraparticle is the porosity within the individual particle. Since the heat from the catalyst and reactant can affect the result, so we should use fine catalyst particle. We should also dilute the catalyst bed with a material like silicon carbide, and also use CSTR or differential reactor in order to study the heat from the catalyst and reactant. We also should minimize the film thickness using moderate or high flow rates and operate the reactor at low conversion. The fourth criteria is minimize temperature and concentration gradient. This gradient is because of the change of the temperature and concentration across the reactor and caused by different and fluctuation in flow of in the temperature and concentration. The gradient can cause the activity and selectivity to disguise. And to prevent this, we should maximize mixing in batch reactor and CSTR to avoid unnecessary heat transfer. And also we should use CSTR or differential reactor where possible. The fifth criteria is to be able to maintain ideal flow pattern. To ensure ideality, gradients should be avoided. And in order to do this, we should minimize mixing in a plug flow reactor since it will create wall effect in which the catalyst and reactant particle will bump into the wall of the reactor and creating energy and heat. We should also maximize mixing in a CSTR since it is a well-mixed reactor and also it minimizes gradients. We should also avoid gas or liquid holdup in multi-phase reaction system. Holdup is a slippage where the two phases, either liquid, gas or solid, where the two of these phases have different velocity and affecting the flow of the reaction. The sixth criteria is maximize accuracy of temperature and concentration measurement. We must well place and use sensitive probes in the reactor to detect and measure the temperature and concentration. We should use sensitive analytical method and we should be able to produce and sufficiently or adequately high product concentration. Okay, the last criteria is we have to meet the reactor is minimum in construction and operating cost. We must select the least expensive reactor that will still satisfy the other criterions. We should also minimize the size of the catalyst and volume of reactant gas used in one reaction. Finally, This is the table of the classification of lab catalytic reactor to ease us in selecting the proper catalytic reactors used for our experiment or reaction. And that's all from us. Thank you and Assalamualaikum warahmatullahi wabarakatuh.
Did you know catalytic of reactor? Thought that we could find out it together. Concept about the reactor, multifunctional and macro reactor. Heterogeneous catalytic reactor, compare reactor, single or multitude for speed up the reaction and separation of the mixture.
Now there's me and you, and we are not alone.
Online learning, we are together now. Catalytic reactor, together we learn this topic. Me and you, we are learning right now. You and me, don't be so lazy now. The reactor, we can see the pace that catalyst can be.